Okay, this is Unit 2 Atomic Theory, Lesson 3, and today we are going to talk about the subatomic particles of an atom. We're going to talk about their names, their mass, their location, and charge. By the time the lesson is over, you will be able to determine the number of protons, electrons, and neutrons in a neutral atom and in an ion. So let's get started. We got a bit to do today. So let's talk about some important vocabulary terms. When you open up your reference tables, you're going to see something that looks like this on your periodic table. It's a key, but it doesn't really go into explanation of what everything is. But it will help you locate certain things in the different element boxes. So I'm pretty sure that most of you know this already up here. This is going to be a review. This is the atomic mass, and it's found in the upper left-hand corner. But what that means is this is the average. I'm going to abbreviate average, AVG, average mass of all the isotopes of the element. And you're probably asking yourself, at least I'm hoping that you're asking yourself, is what is an isotope? We're going to talk about this later on, but I'm going to come down here just so you know. An isotope are two atoms of the same element. So we have, or it could be more than two or more atoms of the same element and they have the same atomic number. So for carbon it would be 6, but a different mass number. And that's because they differ in neutrons. And this is important because there's going to be another word that we're going to talk about, which is called an ion, in which two atoms have the same atomic number but a different number of electrons. So isotopes differ in their neutrons, and ions are going to differ in their electrons. So that brings us to atomic number. Down here, this 6 is the atomic number, and most of you probably all already know that. I'm going to do some abbreviation here. And that's equal to the number of protons. In every atom of the element. So what that means is all oxygen atoms, every single oxygen atom has an atomic number of 8. Every nitrogen atom has an atomic number of 5. Okay, up here in the upper right-hand corner, we have what are called oxidation numbers. And these are going to become useful when we do the redox unit. And these are possible charges an atom can have. So depending on what it bonds with, it might gain 4 electrons, it might give up 2 electrons, or it might give up 4 electrons. And those are the possible charges it can have. Let's move down. On the bottom here on the left, we have what's called the electron configuration. And what this value shows you, the 2, 4, is the number of, and here's the symbol for electrons, E minus, in each energy level. And what's interesting is if you add these up, so in this example 2 plus 4 equals 6, notice how, and this is electrons, notice how these two numbers equal each other. And that's important, okay? Protons equal electrons in a neutral atom because protons are positive and electrons are negative. So if you have the same amount of both, then they're neutral. This is the element symbol, and its sole purpose is to identify the element. Okay, that's a whole lot of information. All right, let's move on. So let's talk about our subatomic particles. Subatomic particles. Proton has a +1 charge. Its relative mass, this is measured in atomic mass units, is 1. Its location is the nucleus, and its symbol is P. And how do we calculate it? It is simply the atomic number. So if the atomic number is 6, the protons are 6. If the atomic number is 8, the protons are 8. Neutron is neutral. It has no charge. It also has a mass of 1. It's also found in the nucleus, and the symbol is N. How do we calculate it? We take the mass number and we subtract the atomic number. And I'll explain why in a minute. And the electron has a -1 charge, and its mass is 1 over 1836. So it's 1 of 1836. So basically the mass is negligible. So what we say really is that the mass is equal to 0 for purposes of this course. And it's found outside the nucleus. Symbol E-. And remember what I said, protons equal electrons in a neutral atom. So, a couple of things that you should observe from this. First of all, in the nucleus we have the protons and the neutrons. And they both have a mass of 1, whereas the electron, which is outside the nucleus, has basically a mass of 0. So one thing that I would write that's really pretty important is most of the mass is located in the nucleus. Sometimes they ask a question about that. So when you're figuring out the neutrons, when you talk about the mass number is really the protons plus the neutrons. So if I know the atomic number and I know the mass number, I can figure out the number of neutrons. Okay. So there are some symbols that we use in nuclear chemistry which also refer to regular atoms. As you can see here, the proton, the neutron, and the electron are listed here. Another name for an electron is a beta particle, and another name for a proton is a hydrogen atom, because hydrogen has just 1 proton and 1 neutron. Let's do some practice with figuring things out. So first of all, they're telling you that the nuclear symbol is chlorine. Remember that this 35 represents the mass number. So that's this. and the bottom number is our atomic number. So this is 17. So how many protons? Well, atomic number tells us the number of protons. And if I know the number of protons, I then know the number of electrons. To find my neutrons, remember, I have to take my mass number. So this is mass number minus atomic number. So 35 minus 17 is going to give me 18. And my symbol, if I were just to write it, would be Cl-35. When we write the element symbol, this number right here that comes after it always represents the mass number. So here we have 15 protons, 16 neutrons. So we need to know what we're talking about here. So the number of protons is our atomic number. So when we look for atomic number 15, on your reference table you'll see that it's phosphorus, P. Its electrons equal its protons. The mass number is going to be protons plus neutrons, which is going to be 31. So now I can fill in the rest of my symbol because I need the mass number. And then down here I've got my mass and my atomic number. And then the last one, we'll pick a different color. We're talking about carbon. Carbon has got an atomic number of 6, which means that it has 6 protons. And it's neutral, which means it's got 6 electrons. The mass number is right here, so that's going to be 14. And then the nuclear symbol would be with the mass number and the atomic number. So in layman's terms, what is the mass number? The mass number is simply equal to the protons plus the neutrons. Nuclear charge. Well, nuclear refers to what's in the nucleus. Charge. With a charge. Well, there's only 2 things in the nucleus, and that is your protons that have a positive charge and your neutrons which have a 0 charge. So the only thing that's got a charge are the protons. So when we talk about nuclear charge, this is another way of asking what is the atomic number. The Regents will say, so what is the nuclear charge of beryllium? When they really could just say, what's the atomic number of beryllium? It's just a backdoor way of seeing if you know what the word nuclear charge means. Nucleons, again, nucleus refers to what's in the nucleus. So this is going to be protons and neutrons. All right, we're almost done. So let's talk about the difference between a neutral atom and an ion. Well, I kind of already hinted a little bit about that. You know that a neutral atom has the same number of protons and electrons. Therefore, that little symbol means therefore, P equals E. Very simple. Forgot my little minus sign there. And we know that protons are positive and electrons are negative. So a positive plus a negative is equal to 0. So that's why we say neutral charge. Let's look at an example. Let's use carbon 12, 6. So this has 6 protons, and you know if it's neutral it also has 6 electrons. So 6 electrons. So what this is really like saying is protons are positive, so this is a positive 6 plus and electrons are negative, a negative 6, which is going to be equal to 0. So how does that differ from an ion? Well, an ion is an atom that has lost or gained electrons. Leaving it with a charge. And then that's the what forms is the ion. So let's start with anion. There's two types of ions, anion and cation. We have to distinguish between the two because one of them has lost and one of them has gained. So an anion is an atom that has gained electrons. So your E is greater than, your number of E is greater than your number of P. So this is going to form a negative ion because you have more negative charges than positive charges. So let's look at fluorine 19(9) with a -1 charge. So by looking at this, we know it's got 9 protons. But this -1 tells us that it's gained an extra electron. And I'll explain why that's what that means in a minute. So this has 10 electrons. So this is like saying a +9 plus a -10 is going to give you a net -1. Well, that is where that comes from. That -1 means it's gained an electron. Let's look at a cation. Well, if an anion was an atom that's gained electrons, then a cation is an atom that has lost or given up electrons. So now your number of E is going to be less than your number of P. And that means that you're going to have a positive ion. And an easy way to remember this one is Are you positive you lost the cat? So cat and cation. So are you positive you lost the cat? Cation is a positive ion. Little bit of chemistry humor there. And an example for that could be 7,3 lithium with a +1 charge. So this 3 tells us it's got 3 protons. The plus means it lost, so it's got 2 electrons. It's just like a +3 plus a -2, which is going to leave me with a +1, which is where that comes from. Okay, that's it for tonight. See you tomorrow.